Today's daily code problem of the day is construct k palindrome strings, number 1400. For this problem, we are given a string called s and an integer called k. We want to return true if we can use all the characters in s to construct a k amount of palindrome strings, or false otherwise. So we can look here at example 1, and what we're looking for is to construct at most or at least 2 palindromes using all the characters in S. So we have to use A, N, B, E, and L to construct 2 palindromes. The explanation gives us 1 to 6 palindromes, but we can look at we use A and N here, and we use E, L, and B here. And that's enough to get 2 palindromes. If we look here at example 2, we have LeetCode. We do not have enough characters to construct 3 separate palindromes that would use all the characters in LeetCode. Here at example 3, we are given the string true. We want to make 4 palindromes, so the only possible solution for this would have a string T, a string R, a string U, and a string E. Those are 4 technically palindromes. So that's all we have to do for this problem. Let's think about palindromes for a second. For a string to be a palindrome, all characters must appear an even number of times, except at most 1 character in the middle. So we could have A, B, C, C. This is a palindrome because, we would have A, C, B, C, A. That is a palindrome because A appears once on both sides, C appears once on both sides, and B appears once right in the middle. So our goal is to get a string with an even amount of characters on both sides. So to create a k amount of palindromes, we need at least a k amount of characters with odd frequencies. The length of the string must be at least k. So s needs to be greater than or equal to k. And from this, we can derive 2 important rules. If the length of s is less than the length of k, or the size of k, we can automatically return false. If it's impossible to form a k substrings, if there aren't enough characters, we return false. Otherwise, we will count the characters with odd frequencies. If the number of odd frequencies is greater than k, then we can return false. Otherwise, it is a possible solution. So our approach for this problem. We're going to solve this problem in 3 steps. 1, we will handle edge cases. So check if s is greater than or equal to k. Simple stuff like that. Then we will use character frequency count. So we're going to count frequency of chars and use bit masking to track characters. The reason we're going to use bit masking is because it allows us to solve this problem in O of n time by simply keeping track of how many of each character appears. Then we can use an odd frequency check, and we're going to count the bits set to 1 in our bit mask and see how many characters have odd frequencies and compare this to k. So if there are more odd freaks than k, false. So let's go ahead and jump right into this code. So these are the 4 steps that we have. First thing is our edge cases. So if our s.length is less than k, we can return false. Otherwise, if our s.length is exactly equal to k, we can return true. The reason we're going to return true is, for example, we have the string s is equal to true and k is equal to 4. Our output would be equal to t r u e, right? So we can make true length 4 into 4 equal outputs, trune. So those are our two edge cases. Otherwise, we're going to use a bit mask to keep track of our odd count. So odd count will be initialized to 0. Next, we are going to update our bit mask. So for each character C in our s.toChar array, simply just make it a char array to make it easier to traverse, we are going to flip the bit corresponding to the character. So odd count will go up equal 1, shifted left, if our C minus A. So odd count will shift left, shift the bit 1 left, depending on how many spaces C minus A is. So if it's A minus A, that is 0. If it's B minus A, that is 1. So on and so forth. And that is going to update our odd count value by making it to the power of 1, the bit shifted to the left, a C minus A amount of times. I can provide a demonstration. So let's say we are starting with our string S is A, B, C, C, and D, and our K value is 3. First, we will initialize our bit mask, so we will set odd count to 0, and that would simply equate to 32 zeros, or it depends on how many, but or 26 bits, I guess we could say, because there are 26 letters. 26 is all we have to worry about. So the bit representation of 0 is just a bunch of zeros. Well, when we start processing the characters in our string by using this, it is going to process each character and shift the bits accordingly. So our first character is A. A minus A is 0. However, we're going to toggle the 0th bit. So we're turning the 0 bit on. So before is all zeros, but A minus A is 0. So we're going to toggle the 0th bit, which makes this a 1. So now odd count is equal to 1. Again, we'll do this for the next A. So we will have A is now toggled off, and that is good because that means A is not an odd number. So we've had 2 A's, 2's even, so that way we have a 0 there representing that A is even. Next, we're going to do B, and it will do the same thing, except in B's corresponding bit. So you can look at this like an array. We're just addressing each one in O of n time. We don't have to go from next, like for each index in the array. We can simply manipulate the bit corresponding to each character. When we get to the end, we finalize our bit mask for AABBCCD. We will end up with this as our bit count. So we have 1D and an even amount of the rest. So we could distribute those evenly across both sides of whatever string we create. However, we only have 1D, so D will need to be in the middle for that string to be a palindrome. Hopefully that helps you better understand what the bit mask is and how it represents our characters. So the last thing we have to do now is we created our bit mask and updated it. All we have to do is return our integer .bit count, and we want to return the odd count. As long as it's less than or equal to k, we should be able to make a palindrome. So if we run this, passes our test cases, and if we submit it, passes all solutions. Thank you, and follow for more daily LeetCode solutions.